Hello and welcome to the second episode of our series about Quarkus and LangChain and how you can use it to integrate large language models like ChatGPT or Hugging Face models into your enterprise service. Last time we showed how you can easily integrate your Quarkus service with a large language model from ChatGPT or Hugging Face. Now, what we didn't cover was how to follow actual conversations. What I showed you last time is only good enough to make single calls to the API and get single results. Today, we want to look into chat memory and how you need to configure it to have actual conversations with a chatbot. So let's dive right in. Like last time, we will start by defining our AI service. I went ahead and already prepared a mail AI service. The idea of this bot is that it will help us write emails and later on also send them. But that's part of another video. Today, we first start with add register AI service on our interface to make sure that Quarkus generates an AI service for this. Then we have a method where we pass in the text from the user and we get back the text that the model is answering. Also, we need to define the system message and the user message again. I've already went ahead and prepared a system message for the model that tells the model to be an AI assistant that helps us writing emails. And the user message is just passed along. So, to actually call our AI service, I went ahead and also prepared a mail resource. The mail resource is just /mails and has a simple get endpoint with a query parameter where we can pass in the query and forward it to our bot. And to be able to use the AI service, we simply inject it here like we would inject any other bean in Quarkus. So let's test this. So the Quarkus service started and we can have a look at Postman. I've already prepared the request where I go to /mails with the query parameter and let's say hi to our bot and see what happens. And as you can see, the bot says hi back to us and tells us what it can do. So let's fire the next request. I want to write an email about how great Quarkus is and can you use something with these bullet points, it's cloud native, super fast and so on. You know how great Quarkus is. And here we get back our email. One thing we directly notice is this took 38 seconds. So the ChatGPT API from time to time can be really slow, especially when you generate bigger messages. So if you have this problem, then you probably run into timeouts. And to fix this, you first need to configure that you want to have a bigger timeout. And you can do this with this property, LangChain, OpenAI timeout, and for example, set it to 60 seconds. Let's have a look at the response from ChatGPT. What we see here is it says best regards your name, but not Andreas. But I told him I'm Andreas. So let's see what Quarkus actually sent to ChatGPT. We see this here in the request. And if we have a look at the model here, we can see that only the system message and the second user message is sent to the GPT model. So our first message got lost. Also, these large language models, they are stateless. So when you want to follow a conversation, then you need to send every message again to them. To make this possible, you first need to make sure that you annotate your mail AI service as application scoped to make sure it's not getting removed by Quarkus again. At the moment, the Quarkus LangChain extension by default marks your AI service as request scoped. The idea behind this is that within a request, you can have a conversation and it will use an in-memory conversation store. However, we have multiple requests and between those requests, it doesn't store the memory. Now there's one more problem. Since we've made this service application scope, the chat memory and the chat messages are basically also application scope now. And so every user that's calling our API shares the same memory and same chat conversation. That's obviously not what we want. So to fix this, we can provide a memory ID to our function. Now, every different memory ID will have a different storage and a different chat conversation. Of course, we also need to pass in this memory ID from our resource. Normally, if you have an application, then you would maybe use the ID, the user ID that you get from the authorization token to pass along. Then you have one conversation per user, or you might look up the latest conversation that the user had from the database and get the ID by this and then pass along this ID. For our testing, we will just simply also use a query parameter. So the service has started. Let's go back to Postman. And here we need to add our user ID first. So we have a user ID of 1. And let's start again with, "Hi, I'm Andreas." So again, we get the response from ChatGPT. Now let's try the second one. I want to send an email and see if he still knows that I'm Andreas. In the meantime, we can have a look at what Quarkus was sending. So we see here the request and the body. And if we copy this over here, we now see there was initially the system message, then the first user message, then the assistant's response, and then the next user message. And the next time there will be the next assistant response and the new user message. So we've got our response. And here we have the result. And here ChatGPT still knows I'm Andreas. So now we can even continue and say, "Hey, I want to write the mail to Bernd Meyer." So we can also add this information, because at the moment here the recipient's name is still empty. So, "Dear Bernd Meyer," and "Warm regards, Andreas." Okay, now let's make another test. What happens if we use a different user, like a different user ID here, and we ask the bot, "What is the content of the email?" And we would expect he doesn't know anything about this email. And when we check here in Quarkus, we already can see that we didn't send anything to this bot. You see here we have a fresh system message and only this user message, and not the rest of the conversation, because that belongs to user 1. And also here in the response, we see that the AI assistant has no clue about our message. And if we go back to user 1, of course, we will now get the result. Here we see again our email. Now there's one problem left. You might be wondering, how many of these messages will you always send to ChatGPT? Because these also count as input tokens, so you also pay money for them, for the old messages. So you can actually configure this in Quarkus quite simply by just going in your application properties and defining the maximum window size. So we can define the memory window, and we can define that it has 20 messages at max. So after 20 messages, it will start dropping old messages. This can help you to define how much context do you want to keep. Of course, if you drop too much context, then ChatGPT loses the conversation or the context of the conversation. If you keep too many of them, it will be more expensive. By default, Quarkus stores 10 of these messages here. There's also a second property where you can define a different type of memory storage. There you can define how many tokens you want to preserve for the next message that you send to ChatGPT. So it's just a different way of defining how much context you want to keep. Now, I've told you before that Quarkus by default uses an in-memory store. And if you have now a couple thousand users for your service and they all enter their messages here and ChatGPT responds with his messages, then you might run into the problem that you run out of memory because you cannot just simply store all these messages in memory. So it's important to also think about how you can clean up the memory. To do this, Quarkus offers a simple method, and we can just add a new REST endpoint to do this. So I've defined a new method, the delete method, on /conversations. And here we can have call the chat memory remover, or the remove function of it. And we pass in our AI service for which we want to clear the memory and the memory ID. In our case, we use our user ID here. Of course, in the real-world application, you wouldn't do it like this with a REST endpoint, but more with some logic either inside your Quarkus, or you would change the memory strategy to not store it in memory, but maybe in a database, for example, with Hibernate. If we now have a look at this and we make our call, again, I set up a new conversation with ChatGPT. And to delete my conversation, I can then simply remove this memory again. And when I now ask him to write an email, again, we can check the request here. When I check the request in the logs again, we can see that we have a fresh conversation directly starting with the system message and only the user message we just sent and not with the old messages. So that's how you can clean up the in-memory store. If you don't want to use an in-memory store to store the messages in memory, but rather, for example, store them in a database, you can also define your own memory store. To do this, you simply define your own memory bean. This bean needs to implement the chat memory store. And of course, we made a bean actually. And then we can implement 3 methods. The first method is get messages. The second one is update messages. And the third one is delete messages to remove messages from the store again. Since this is a normal Quarkus bean, you can just inject anything else you want to use here. For example, you could use an entity manager. I don't have Hibernate in this project now, but you could just inject an entity manager or a Redis instance to store your messages there. So that's how you can configure the memory to store chat messages between API calls, so you can have a real conversation with ChatGPT or Hugging Face models and don't lose the context in between. Next episode, we will have a look into agents and how you can make ChatGPT call your Quarkus functions. So please like and subscribe so you don't miss the next video. See you next time.